Alrighty, so welcome to Discrete Random Variables. So what we're going to be looking at today is how do we actually go about talking about what this topic's even about. So what does discrete mean? Well, discrete usually comes as an antonym or as a kind of an adjacent idea as continuous. So discrete means that we have selective input. So imagine you roll a dice, what can you get? Well, you can get a 1, a 2, a 3, a 4, a 5, or a 6. These would be discrete outcomes. You either get a 1, a 3, or a 4. You can't get 4.5 in a discrete world. Random just means that you've got to have different chances for things, and variables just means we're going to be doing it in terms of how do we actually measure the chances of these things happening. Alrighty, so let's have a look at a quick example. So, a fair coin is tossed 4 times. Determine the probability of obtaining exactly 2 heads. Alrighty, now there's a few ways we could go about tackling this problem. I think a very simple way is to do a quick tree diagram. So, in the first round, we've got 2 options, either heads or tails. And then on the second coin toss, we could either get heads or tails. And similarly going throughout. And this is going to continue for 2 more flips. Alrighty, so this is the outcome, and you can see that in total there are a grouping of 16 outcomes, and that comes from the fact that there's 2 outcomes in the first round, 2 outcomes in the second round, 2 outcomes in the third round, 2 outcomes in the fourth round. So in total, 2 times 2 times 2 times 2 gives us 16. So that's where these 16 outcomes come from. And we're only interested in the outcomes in which you get exactly 2 heads. So we could list them all out, or we could just look for them. So we could get 2 heads in a row, and then 2 tails. That would work. Now that's the only one that's going to work, because in all of these other cases here, they're going to get us some amount, too many heads. So we could get a heads and then a tails, and then a heads. Those are our 2 heads, so then we'd have to get a tails. So heads, tails, heads, tails. We could do get a heads, get a tails, get another tails, but finish with a heads. We could start with a tails, get 2 heads in a row and then a tails. We could get a tails, heads, tails, and then another head. We could get 2 tails and then 2 heads. And those are the outcomes. And we can write them down. And we can see these are all of the different outcomes in which you're getting exactly 2 heads. And then we got H, H, T, 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 H, H, T, sorry. And continuing on. Alrighty, so those are all of the different ways that you can get to exactly 2 heads. And you'll notice that there are 1, 2, 3, 4, 5, 6 outcomes out of a total of 16 total things. So 6 out of 16. And 6 out of 16 simplifies to 3 out of 8. And that would be our final answer. Alrighty, so that's where every probability has the exact same chance, a half and a half. How else can we deal with it when the probabilities are not so simple? So, a goal attack in netball scores a goal from 75% of her shots. How many shots at goal would she need to take before she'd have at least a 95% chance of scoring at least 1 goal? Alrighty, so let's have a think about it. So, rather than thinking about percentage of hits, let's think instead in the reverse. How many misses can she get? Alrighty, so 95% chance of scoring at least 1 goal. Well, that means that we're looking for a probability of less than 5% that she misses all of her shots. Alrighty, so what's the probability that she misses 1 shot? So let's say M is a miss. Alrighty, so what's the probability of M? Well, since 75% of the time she hits the goal, well, that means that 100% minus 75%, 25%. Or probably better written either as a quarter. Actually, I'm gonna write it as a decimal, so 0.25. All right, so then what's the probability of getting 2 misses? Well, by the probability rule, when you have repeated things, you're going to multiply them together. So 0.25 times 0.25 equals 0.0625, which is still greater than 5%, right? Because this is a percentage, would be percent, 6.25%, but it's 0.0625, which is bigger than 5%, and we need something smaller than that. So let's look at the probability of 3 misses in a row. And you'll notice that since we're just going to be timesing it by 0.25 3 times, I may as well just write to the power of 3. Speed things up. And we get 0.015625, which is equal to 1.5625%, which is indeed less than 5%. So therefore, she would need 3 shots. To have a 95% chance of scoring at least 1 goal. Alrighty, so that's just a little bit of revision on some simple probability questions. I'll see you in the next one. Bye.